everyone, myself Rakhi Kumari, Assistant Professor in the Department of Electronics and Communication Engineering, ABS Engineering College, Ghaziabad, affiliated to Dr. APJ Abdul Kalam Technical University, Lucknow. Today in the lecture series of Microwave and Radar Engineering, I am going to teach you Passive Microwave Devices Part 1. In this series, I am going to teach you Magic T, Hybrid T and the Directional Coupler. So, first of all our Magic T. So, what we have assumed here that it is a 4-port T, 2 collinear port and 2 auxiliary port. So, if we are assuming that port 3 which is our H arm will behave as a property of our H plane T and the port 4 which is our E arm will behave as a E plane T. So, whenever power is given to the port 3 which is our H arm, it will come out of the port 1 and the 2 with same phase and equal magnitude. And whenever power is given inserted from the port 4 which is our E arm, power will come out of the port 1 and the port 2 same magnitude but opposite phase. And the reverse thing, whenever power is given to the port 1 and the port 2 and they are of equal magnitude and same phase, it will come out of the H plane, and whenever power of the same magnitude and opposite phase are given to port 1 and the port 2, it will come out of the port 4. These are the 4 basic properties and the characteristic of our Magic T, and the same thing are written here. If the two power of equal magnitude and same phase are fed into port 1 and the port 2, the output will be 0 at port 4 which is our E arm and additive at the port 2. If the wave is fed into the port 3 which is our H arm, it will divide it equally between the port 2 of the collinear arm and it will not appear at port 4 which is our E arm. And if the power is fed into the port 4 which is our E arm, it will produce an output of equal magnitude and opposite phase at port 1 and the port 2, and the output will not appear at the port 3. And if the wave is fed into one of the collinear arms of the port 1 and the port 2, it will not appear in the other collinear arm port 2 or the port 1. The E arm causes a phase delay while the H arm causes a phase advance. So, these are the main interpretation, and when the power is given to one of the collinear arm, it will not appear at the other collinear arm. If the power is fed into the port 1, it will not appear at port 2, and if the power is given to port 3, it will not appear at port 4. So, as per this now the S matrix analysis of our Magic T. Magic T is a 4x4 matrix because it contains the 4 port. So, basic matrix is given like this, and now one by one, for getting the exact matrix, we are going to apply our properties of the Magic T. The first property say Sij is equal to Sgi, which is a symmetric property. So, as per this, what will happen? This row will remains the same, there will be no difference. The basic difference arises from the row second. S21 changes into the S12 and other remains same. S31 changes into the S13, S32 changes into the S23 and other remain same. Now, in the fourth row, S41 changes into the S14, S42 changes into the S24, S43 changes into the S34. Now comes our the H-plane T. H-plane T is our third port. So, as per the H-plane T property, S23 should be equal to S13, and as per the E-plane property, what will happen? S24 is equal to minus of S14. So, what we have assumed here, out of the 4 port, this will be our H arm and this will be E arm, and E arm there is a change in the phase. Now, as per the geometry, as we see, know that whenever power is given to one of the collinear, it will not appear. So, if the power is given to port 3, it will not appear at port 4, and if the power is given to port 4, it will not appear at the port 3. So, S34 is equal to S43 should be equal to 0, and if we are assume that the port 3 and the port 4 are perfectly matched. So, perfectly matched means, so if the power is given to the port 4, it will never return back to the port 4. In that case, S44 should be equal to 0, and similarly, if we are assuming that the port 3 is perfectly matched, so if the power is given to port 3, it will not come back to the port 3. So, S33 in that case should be also be equal to 0. So, the matrix changes into what? What we have taken? S23 is equal to S13, S24 is equal to minus of S14. So, this will remain same, S12, S22, and the place of S23 we have to write S13. So, here at the place of S23, S13, and at the place of S24 we have to write S14, E plane property, and this is the H plane. So, S24 should be equal to minus of S14. Similarly, S31 is equal to S13 as per the symmetry. So, here we have S23 which is replaced with S13, and S33 should be equal to 0. And similarly, what is having? S33 should be equal to 0 as per the matched condition. S34 collinear arms, S34 collinear arm that should equal to 0, and S44 should be equal to 0 as per the match port. And here it is S14, and this is the S24 should be replaced with minus of S14. Now, in the third step, we are going to apply the unitary property. As per the unitary property, whatever matrix we have multiplied with the conjugate, and in turn it will give the unitary matrix, identity matrix. This is the matrix we are getting. So, when these two are multiplied and then we relate to this one, we exactly able to get S13 is equal to 1 by under root 2, S14 is equal to 1 by under root t, S11 is equal to S12 is equal to 0, which further gives S22 is equal to 0. From this relation, we comes to another conclusion, that is S11 should be equal to S22 is equal to 0. This interpretation exactly proves that port 1 and port 2 are also perfectly matched to the junction. This we get after, we are not assumed this initially, but after the calculation and after the complete derivations, we are able to get come to this conclusion. And this is basically the magic which exists in the magic T. So, if the two arms of the magic T are matched, we the other two arms also are get perfectly matched, and this is the magic behind the magic T, and that is why it is named as a magic T. So, at the end we are able to get this matrix as the our final one. This will remain the 0, another one 1 by under root 2, 1 by under root 2, 1 by under root 2 minus 1 upon under root 2, 1 upon under root 2, 1 by under root 2, 1 by under root 2 and minus 1 upon under root 2. So, students, all of you just write the matrix which we have obtained here, that is S11, S12, S13, S14, S12, S122, S22, S13 minus of S14, S13, S13, S14 minus of S14 in the this one, and thus then do the matrix calculation and then equate it to this to get this equation. So, take this as a assignment or a work assigned to you and try to solve it, so that you will able to get the complete matrix of the magic T. Now comes the application of the magic T. Application of a magic T plays a very important role, because as per that we are able to get the use it as a mixture, as a duplexer and for impedance measurement. So, the first diagram which we am showing here is the diagram arrangement of magic T for the calculation of impedance. So, in that case we have a 4 port here. So, in the one port we have a standard variable known impedance, and in the port 2 we have a unknown impedance and one null detector and one microwave source. So, this should be the arrangement if we want to calculate the unknown impedance using the magic T. Now, magic T can also be used as a duplexer. So, what the first question arises, what is the duplexer? The duplexer is the medium in which a same antenna can be used as a transmitter as well as the receiver section. So, here is the arrangement of a magic T for the using it as a duplexer. In the first 2 port, receiver and the transmitter, in one port there is a match load and in the other there is an antenna. So, in that case we can use the magic T as a duplexer, and in the second case, third case, magic T can be used as a mixer also, and for that the arrangement exactly like this. So, basically what is the thing, in the mixer what we have, incoming signal, match load, local oscillator signal and local oscillator signal. So, local in the mixer what we do, it gives the basically difference between the signal coming and the local oscillator to get the intermediate frequency RF. So, we can IF. So, we can use the magic T for getting the IF, that is intermediate frequency also, and thus it can be used as a mixer. Now comes the turn of a hybrid ring or a rate raz circuit. So, basically what is the hybrid ring? Hybrid ring consists of annular line of proper electrical length to sustain standing waves to which 4 arms are connected at a proper interval by means of a series of parallel junction. So, what is basically 4 arms are connected, 1, 2, 3 and 4. 4 arms are connected which are differentiated with each other with a particular length. For example, port 1 and port 2 are differentiated with a lambda g by 4, port 2 and port 3 lambda g by 4 and port 3 and port 4 by lambda g. But if you are able to see, we already know that when the power is given to one port, it will be appear at the other port when they have a same phase. When there will be opposite phase, then the power will not appear at that port. So, you are able to see that between the port 1 and 3, distance will be different. Between the port 1 and 2, distance is different. Distance between 1 to 4, again the difference is different, and between, so every port has got a different distance. There is not a common distance between the two adjacent or different port. So, in that case that is the reason behind the getting the signal at one and not getting at the other. So, when a wave is fed into the port 1, it will not appear at port 3 because the difference of phase shift of the wave travelling in the clockwise direction and the counterclockwise direction is 180 degree. So, what we are actually having here, when the two way, when we gave the power to port 1, first power, when the power is given to port 1, one of the power will go like this and the other will go like this. So, when we see they are talking about the port 3. So, between the port 3, lambda g by 4 for the first, lambda g by 2 plus lambda g by 2, that is lambda g by 2, and this way lambda 3 lambda g by 4 plus lambda g by 4. So, this will be 4 lambda g by 4 and here it is lambda g by 2. So, what is the difference? Difference will be again lambda g by 2, and when we talk about the phase, it will be equal to pi, which is equal to 180 degree. So, this thing is saying in this line, when a wave is fed into the port 1, it will not appear at port 3 because the difference at the phase shift of the wave travelling in the clockwise and the counterclockwise direction is 180 degree. So, this thing we are able to see, if we have taken the direction in both and the difference comes to be 180 degree, that the power which is fed into the port 1 will not appear at the port 3. Similarly, we will check for other ports also. When a wave is fed into the port 2, it will not appear at port 4 because of the difference of the phase shift, which is again equal to 180 degree. So, I think all of you are able to calculate this, ki when a power is given to port 2, it will not appear at port 4, it is saying. You are able to calculate, this will be at the lambda g, and this way it will be lambda g by 2, again difference will be lambda g by 2 and 2 pi by phase shift beta is equal to 2 pi by lambda is equal to pi, that is equal to 180 degree again. So, in this way we will able to get at which port when we give the power will be received. When a wave is fed into port 1, it will appear at port 4 because of the same phase. So, let us see one example of that also. When we give the power to port 1, it will appear at port 4. What is the difference here? Lambda 3 lambda g by 4, lambda g by 4, and here also 3, same phase, the power will able to appear. So, in this way we are able to get the matrix of a ray trace circuit or the hybrid circuit. I think every one of you understand now how we were able to get the matrix. In that way we are able to get this matrix of a magic T, of a hybrid T, that is also called as the ray trace T. Now comes the turn of a directional coupler. Directional coupler consists of it is also a 4-port waveguide junction, and it consists of a primary waveguide 1 to 2 and a secondary waveguide 3 to 4. This is our primary waveguide and this is our secondary waveguide. When the all ports are terminated in their characteristic impedance, there is a free transmission of power without reflection between port 1 and port 2. So, what is this saying? That if all the ports are terminated in their characteristic impedance, in that case there is a free transmission of power without reflection between port 1 and the 2, and there is no transmission of power between port 1 and port 3 when all the ports are fed by their characteristic impedance, or between 2 and 4 because there is no coupling exists between these 2 points. So, when the power is fed to port 1 and all the ports are perfectly matched, it will not appear at port 3 and it will not appear at port 4 when the power is given to port 2. Now, as per this, there is some important characteristic of a directional coupler. First one is the coupling factor, and it is a measure of ratio of the power which is coupled. So, power is coupled between the port 1 and port 4. That is why our coupling factor is decided on this basis. And all of you should know, when we talk about the say we have a 10 dB coupler, we have a 20 dB coupler, what we are seeing like this, we are basically saying their coupling factor. 20 dB coupler means its coupling factor is 20 dB. 10 dB coupler means its coupling factor is 10 dB. And now comes the directivity. So, directivity is basically, it is a ratio between the port 4 and the port 3. Port 3 is the port where we have the backward wave, and basically it is avoided. P1 power input to port 1, P2, P3 power output from port 3 and port 4. Now, these are the some basic directional couplers: 2-hole directional coupler, 4-hole directional coupler, scavenger coupler, and the primary wave Beth hole directional coupler, which consists of a rotated secondary guide and the primary guide. So, basically all the coupler consist of primary and the secondary wave guide. So, let us have an example of a 2-hole directional coupler. The main reason is that using here, it consists of a 2-hole, first hole and the second hole. Power is given to port 1, and accordingly as somewhere there is a same phase and somewhere it is opposite phase, and according to that it is decided whether the power will appear at which port and get cancelled at the other port. So, when the power is given to port 1, what will happen? It will first go this way and again go this way, and it will go through this hole, and one will go like this, and whenever it comes like this, again one will go like this and one will go like this. This is our the wave which is coming from this side, one will go like this, another will go like this. And what we have to get it here, we are basically have to calculate the phase difference. So, length, here it is lambda g by 4 when we assume that n should be equal to 0. So, the first wave which is coming here, second one, the first one is, goes like this, the second one which is coming has to cover lambda g by 4, and it comes out of the and reaches here lambda g by 4, and the one without any 0, first one, and second which is goes like this again has to cover a lambda g by 4 and it come here, the second one lambda g by 4. So, they are in the same phase, and that is why it will be additive here. But the second one which is coming from this and has to go this way, the first wave already has a 0 distance traveled, but second one which is coming here has covered lambda g by 4 first, and again after coming lambda g by 4 plus lambda g by 4. So, it will be lambda g by 2. So, 0 and lambda g by 2 opposite phase, that is why the wave get cancelled at the port 3. So, this is the basic reason working of the 2-hole directional coupler, and same thing is interpreted here. The fraction of the wave energy entered to port 1 passes through the holes, and let it into secondary waveguide as the whole act as a slot antenna. And as per that, we are able to get the matrix of a directional coupler. All ports are assumed to be matched, that is why this condition. There is no coupling between port 1 and the port 3 and between port 2 and the port 4. So, this, and as per this matrix we are able to get. And now applying the property of the S matrix. First, 0 property, where we say that S multiplied with the conjugate of S will give the 0 matrix. We are able to get this relation and this relation. And again by applying the unity property, we get the identity. S multiplied with conjugate, we get I, that is our identity matrix, we are able to get. So, by equation 1, 2 and 3, we are able to get this two relation where S12 is equal to S34, S14 is equal to S23. So, by solving the conditions which exist for the directional coupler, we are able to get this matrix of a directional coupler. So, all of the students are instructed to try to solve this matrix, because by using the different properties which is mentioned here, so that you can able to get the exact matrix of a directional coupler. Thank you for attending today's lecture.